Welcome to the deep dive. We're really glad you are joining us today.
Yeah, absolutely. Thrilled to be here.
Because if you've looked at any screen, anywhere, in the last 24 hours, you already know what we're covering today.
Oh, it is everywhere.
It really is. Today is Thursday, March 5, 2026, and the timelines are just completely saturated with these leak videos.
Yeah, the OpenAI GPT-5.4 leaks.
Exactly. We're seeing titles like OpenAI GPT-5.4 leak shocks the internet with massive power, and suddenly everyone is an expert on this new phrase.
Vibe coding.
Yes, vibe coding with GPT-5.4. The hype cycle is in absolute overdrive right now.
It really is deafening.
It is. But if you're feeling a bit overwhelmed by the sheer volume of hot takes or, fragmented Twitter threads, just take a deep breath. You are in the right place.
Because it's incredibly easy to get swept up in the viral demonstrations, right?
Oh, for sure. The flashiness of it.
Exactly. Watching an AI seemingly build a complex web application from a single casual voice command, it looks like magic. But our mission today is to cut through that surface-level noise.
We are doing a custom-tailored deep dive just for you.
Right. We're examining the fundamental paradigm shift that these leaks are actually signaling. We're pulling apart the underlying architecture of what is being called agentic workflows.
Agentic workflows.
Yeah. And to be clear, this is not just a faster chatbot.
Right. It's not just a more articulate text generator.
No, it is a complete transition from AI functioning as a reactive tool to AI operating as a proactive, autonomous worker.
And we are going to build a complete mental model for you today of how these workflows operate. We're going to look under the hood at the new software stacks.
We'll explore the massive physical and geographical infrastructure making this possible, too.
Yeah, the data centers. And we'll discuss exactly what this shift means for your own career and business. So, okay, let's unpack this.
Because there's a core analogy here that really sets the foundation.
Yes, from the source material, the manifesto called Netizen, GPT 5.4, and the rise of agentic workflows. Think about the AI we were all using back in the early 2020s.
Right, the era of the original GPT-4 Claude 3.
Exactly. That generation of AI functioned like a highly intelligent but entirely reactive intern.
Very reactive. You ask it a question, it gives you an answer.
Right. You type a prompt, it generates a paragraph of text, or maybe it spits out a Python script. But after it generates that output, what does it do?
It just stops.
It just stops. It sits there with a blinking cursor waiting for you to tell it what to do next.
It's fundamentally a tool that requires continuous human steering. But these new reasoning models, specifically the ones powering these GPT 5.4 leaks, they flip that entire dynamic.
Right. The transition is moving from a dynamic of responses to a dynamic of actions.
Yeah, the new generation acts much more like an autonomous project manager.
So in the old dynamic, you might say, write a marketing email for my new products.
And the AI writes the text.
But then you, the human operator, you have to copy that text.
Open your mailing software.
Format the email, segment your customer list, run a spam check.
And finally hit send.
Right. The human is the glue holding the entire process together.
But the new dynamic is you simply saying, run my marketing campaign for the new product.
Run my campaign. That's huge.
It is. The AI takes that high-level objective, breaks it down, and independently manages the entire multi-step process across various software environments.
It turns AI from a singular, isolated tool into a coordinated system of digital workers.
Exactly.
That is the pivotal shift right there. Write an email versus run my marketing campaign. And just think about how much of your day right now is spent just acting as that human glue.
Moving data around.
Yeah, you pull data from an analytics dashboard, you paste it into an Excel sheet.
You summarize it into a Slack message for your team.
You update a ticket in Jira. You are just moving information between silos.
And what we are exploring today is the transition from a prompt response cycle to a goal execution cycle.
Goal execution. And to really understand how this works, we need to break down the anatomy of an agentic workflow. The Netizen Manifesto lays out 5 distinct steps to this process.
Right. Understanding these 5 steps is the key to seeing past the magic tricks on social media.
Step 1 is understand a goal.
So instead of a highly specific engineered prompt, you give the system a vague, high-level instruction.
Let's use a tangible example.
Okay, say you tell the agent, launch a product landing page for my new predictive inventory tool for coffee shops.
A reactive AI would just write some decent copy about coffee beans and stop.
Exactly. But an agentic AI infers the unstated underlying objectives required to actually accomplish a launch. It knows launch means more than just words on a page.
Which leads right into step 2, task decomposition.
Yeah, it breaks it down.
The AI takes that inferred objective and independently builds out a comprehensive to-do list.
So for this coffee shop SaaS landing page, it maps out the entire project.
It flags that it needs to conduct market research on local coffee shop pain points.
It performs competitor analysis on existing inventory tools.
It writes the targeted copywriting, designs the UI layout,
Implements SEO optimization, sets up Google Analytics tracking.
and finally deploys the code to a server.
It is building its own roadmap without you prompting it step by step.
Which is wild. And here is where the critical divergence from traditional AI happens. Once it has that roadmap, it moves to step 3. Execute actions using tools.
Right. The agent actively reaches out into the digital environment. It isn't just generating text in a vacuum anymore.
It's invoking APIs.
It's querying live databases. It opens a headless web browser to scrape competitor pricing.
It interacts with Figma for design assets.
It writes the React code, pushes it to a GitHub repository, and updates your CRM system to prepare for inbound leads.
It is operating within the exact same software ecosystem that a human developer or marketer uses.
Which is incredibly powerful.
I see the appeal of that level of automation. I really do. But let me play skeptic for a second. In theory, that sounds incredibly efficient. But in practice, what happens when it hits a roadblock?
That's the big question.
Right. Like, if it hallucinates the competitor analysis, doesn't it just blindly build a broken, poorly positioned website? How does this process actually survive contact with reality without a human constantly checking its work?
That is exactly the right question to ask, and it brings us to step 4, which is arguably the most important breakthrough here.
Self-evaluation.
Yes. These agentic workflows are not fire-and-forget missiles. They incorporate built-in evaluation loops.
Meaning, after the agent drafts the code in the copy, it doesn't just deploy it.
Exactly. It evaluates its own output against the initial goal. It runs internal queries.
Like asking itself, is this page loading under 2 seconds?
Or, are the SEO keywords actually aligned with current search volumes for coffee shop software?
Is the mobile responsiveness functioning correctly?
Right. It acts as its own quality assurance tester.
So it's essentially running a localized critique of its own work.
And that triggers step 5, the iteration phase.
Right. If the answer to any of those self-evaluation questions is no,
Say the page load is too slow or the copy is generic.
it doesn't just give up or wait for you to fix it.
No, it initiates an iterative loop. It goes back, refines the code, tweaks the image sizes, adjusts the copywriting, and then reevaluates.
It repeats these continuous cycles until the output crosses a predetermined quality threshold.
You are no longer holding its hand through every micro adjustment. It handles the friction of execution entirely on its own.
When you combine task decomposition, tool use, and self-evaluation, you completely redefine the nature of digital labor.
What's fascinating here is that the AI is now responsible for managing the process itself. It absorbs the cognitive load of execution.
And leaves the human to simply set the direction.
Exactly.
Let's look under the hood, though, because talking about an AI managing a process can sound a bit like science fiction, or at least like we are anthropomorphizing code a bit too much.
Yeah, it's easy to fall into that trap.
But this is real software running on servers right now. So we need to examine the architecture of this autonomy, what the source material calls the AI agent stack.
Right.
Because this isn't just one giant monolithic brain doing everything simultaneously.
Not at all. It is a highly structured, layered architectural system. It is a completely new paradigm in software architecture.
For the last 20 years, we've understood traditional web application stacks.
Front-end, back-end, database.
Right. But now we're seeing the rapid maturation of the AI agent stack.
Let's peel back the layers. Layer 1 is the foundation models.
The cognitive engines.
Exactly. This is your GPT-5, your GPT-5.4, your Claude, your Gemini. This layer provides the raw processing power,
The complex reasoning.
the natural language comprehension, the spatial planning capabilities, and the core coding logic.
Like the foundation model alone is just potential energy.
Yeah, an unprompted instance of GPT 5.4 doesn't do anything by itself.
It needs a structure to direct that reasoning. And that brings us to layer 2, orchestration frameworks.
These are the open source and enterprise tools like LangChain, AutoGPT, CrewAI, and Semantic Kernel.
If the foundation model is the engine, The orchestration framework is the transmission and the steering wheel.
That's a great way to put it. It sits directly on top of the model and manages the logic loops.
It handles the task planning algorithms
It dictates when the AI should evaluate itself.
and coordinates how different subtasks are routed.
Then we step down to layer 3, which is tool integration and the environment layer.
This is the API gateway.
Yes. This is where the agent actually touches the external world. We're talking about authenticated integrations with Slack, Stripe, AWS, Notion, and headless browsers.
So this layer translates the AI's intent. So the intent is charge this customer $50.
Right. It translates that intent into the specific JSON payload required by Stripe's API to actually execute the transaction.
The agent doesn't just output the idea of a transaction, it executes the reality of it. But the layer that truly makes this an autonomous system, the layer that separates a neat parlor trick from a sustained workflow, is layer 4.
The memory systems.
Yes. Because if we are replacing human operators, we have to replicate how humans track ongoing work.
If an agent cannot remember what it did an hour ago,
Or what failed during a test run yesterday.
it can never successfully complete a complex multi-day project.
It would just be stuck in a permanent state of amnesia, restarting the task over and over.
Memory is the nervous system of an agentic workflow. True autonomy is impossible without it.
And the Netizen text outlines that these advanced systems utilize 4 distinct types of memory, which mirror human cognitive structures quite closely.
The first is short-term, or working memory.
This is essentially the context window of the model, right?
Exactly. It holds the immediate active conversation history, the intermediate steps it is currently processing, and the active state of the task right at this second.
It is what the AI is holding in its head while it executes a specific function.
But working memory is volatile. As soon as the context window fills up or the immediate task concludes, that information is flushed.
So, for persistent knowledge, you move to the second type, long-term memory.
Yes.
Now, for those who haven't been deep in the engineering side lately, let's clarify how this actually works, because this isn't just saving a text file to a hard drive.
No, not at all. Long-term memory is stored externally in vector databases.
Technologies like Pinecone, Weaviate, or Milvus.
Right. And a vector database is fundamentally different from the SQL databases we've used for decades.
How so? Let's break that down.
Well, a traditional SQL database stores data in rigid, predefined rows and columns. It requires exact keyword matches to retrieve information.
Right, you search a specific string of text.
But a vector database converts text, images, or code into high-dimensional mathematical vectors.
It's essentially plotting concepts in a multi-dimensional spatial relationship.
Exactly. This allows the AI to search by semantic meaning rather than exact keywords.
So if the agent researched a competitor a month ago, it doesn't need to query the exact brand name.
No, it can query the mathematical concept of competitor pricing strategies in the coffee niche and instantly retrieve that specific contextual data back into its working memory.
That semantic retrieval is incredible. And it's what enables the third type of memory, which is episodic memory.
This is where things start to feel incredibly advanced.
Yeah, episodic memory is where the agent records its specific past experiences, categorizing its successes and its failures.
It remembers that a specific tone of voice in an email campaign last week yielded a 40% higher open rate.
Or that a specific library it tried to use in a Python script caused a dependency error,
It is logging its own history to inform future decisions.
which naturally feeds into the fourth type, procedural memory.
Right. This is the storage of actual refined skills and complex workflows.
So if a marketing agent successfully figures out the optimal multi-step process for running an A/B test on a LinkedIn ad campaign, it stores that procedure.
And the next time you ask for an A/B test, it doesn't have to deduce how to do it from scratch, using its foundation model reasoning.
It simply retrieves the optimized procedure from memory and executes it.
Exactly.
And the mechanism that ties all these memory types together is the reflection loop.
Yes. Advanced agents periodically pause their execution to run a background reflection process.
They review the log of their recent tasks.
They analyze the deltas between their expected outcomes and the actual results,
They extract the core lessons.
and then update their vector databases.
They are mathematically consolidating their memories to become more efficient. They are engaging in structural self-improvement.
What's fascinating here is that this is where the exponential value of agentic workflows becomes apparent. They don't just do the work, they actively optimize the way they do the work.
Imagine a growth agent tasked with optimizing a landing page.
It generates 5 different variations of copy, deploys them, monitors the live traffic, identifies the winning variant,
Analyzes why it won,
updates its procedural memory with that insight.
and then generates 5 new, more refined variants.
It is a continuous AI-driven experimentation loop that operates without human intervention.
Here's where it gets really interesting. Because a single agent optimizing a landing page is impressive, but it's just the beginning.
Oh, absolutely.
The framework we are exploring today introduces the concept of multi-agent orchestration.
We aren't just giving one monolithic AI a massive list of disparate tasks.
No, we are spinning up an entire digital corporate team composed of highly specialized, narrow agents that collaborate and communicate with each other.
It is a fundamental reorganization of digital labor. Let's look at the example from the text, the fully agentic startup workflow.
Right. Instead of a human founder trying to juggle 20 different roles or hiring a large initial team, they deploy a multi-agent system.
You begin with a research agent.
Its entire narrow focus is to scrape industry reports, analyze competitor SEC filings, monitor social media sentiment,
And identify specific unaddressed market gaps.
Once the research agent finalizes its dossier, it doesn't just stop. It hands that structured data over to the strategy and planning agent.
And this agent isn't allowed to browse the web. Its only job is to consume the research and output a business strategy.
It defines the core product features, calculates the optimal SaaS pricing tiers based on the competitor data, and writes the overarching brand positioning document.
That strategy document is then routed to the builder or coding agent.
This agent takes the feature requirements and begins architecting the application.
It writes the back-end database schemas, builds the API endpoints, and integrates the payment processors.
Concurrently, a design agent is interpreting that same strategy document.
Right, to generate the UI components, establish the color palettes, and create the brand assets.
Then the marketing agent receives the finalized product specs and the design assets.
It writes the public-facing copy, optimizes the entire site architecture for search engines, and prepares the launch materials.
You have a growth agent setting up the programmatic ad buying and A/B testing pipelines.
And sitting above all of this is a manager agent.
The manager agent.
Yeah.
And it doesn't write code or copy,
No, its function is purely to monitor the orchestration layer,
ensuring the coding agent and the design agent are adhering to the timeline
resolving conflicts between agents.
and reporting high-level progress back to the human founder.
It operates precisely like a modern, agile corporate team.
But the economic implications of this architecture are staggering.
They really are, because this digital workforce operates 24 hours a day, 7 days a week.
They do not experience fatigue,
They do not require benefits.
and they operate at a near-zero marginal cost.
The traditional cost structure of building software, conducting deep market research, or executing a comprehensive marketing campaign fundamentally collapses.
We are essentially taking the middle management layer of the corporate world and replacing it with a localized API call.
It's a profound shift.
That is a terrifyingly efficient thought. Think about how this applies across the broader economy.
Well, in software development, we've seen early glimpses with reactive tools like GitHub Copilot.
Right, but we are moving towards semi-automated pipelines, where the human reviews architecture, while the agents handle the generation, the debugging, the security patching, and the deployment.
In research and intelligence, multi-agent systems can conduct exhaustive literature reviews, cross-reference decades of scientific papers, and propose novel hypotheses in hours instead of months.
And in supply chain operations, agents are negotiating dynamically with vendor APIs to optimize logistics routes in real time.
This forces us to confront a significant shift in labor economics.
The equation is shifting.
Exactly. If the marginal cost of operational labor is approaching zero and multi-agent systems are handling the execution, the role of the human must evolve.
The human becomes the strategic director. The AI agents become the operational workforce.
You, as an individual professional, are no longer valued for your ability to execute tasks quickly.
You are valued for your ability to supervise, direct, and optimize a fleet of specialized AI agents.
Which brings us to a concept that is gaining immense traction, the solo unicorn.
The solo unicorn. The idea that a single individual could build and scale a billion-dollar enterprise supported entirely by a digital workforce.
The human acts purely as the strategic brain, identifying the market dislocation, setting the vision, allocating capital.
While the multi-agent system executes every single operational detail, from writing the code base to handling customer support.
And while the solo unicorn might sound like an extreme edge case, the underlying mechanics of hyperautomation make it theoretically possible.
And it raises complex questions about economic concentration. Is an economy driven by solo unicorns a net positive?
Right. On one hand, you have unprecedented productivity and innovation happening at light speed.
On the other hand, you sever the traditional link between company growth and job creation. A company no longer needs to hire 10,000 people to reach $1 billion in revenue.
And the value of these solo operations compounds aggressively because of the self-improving nature of the workflows.
The founder doesn't have to manually train the sales team.
No, the sales agent analyzes 1,000 lost deals, identifies that prospects drop off when pricing is mentioned too early,
Updates its procedural memory.
and improves the close rate on the next 1,000 interactions.
The company grows and optimizes autonomously based on reinforcement signals like revenue and engagement.
But we need to ground this conversation in physical reality.
Yes, absolutely.
Because talking about agents, vector databases, and digital workforces makes it sound like this all exists in some ethereal cloud.
Right, it does not.
Yeah.
Where does this AI actually live?
These systems require a staggering amount of physical infrastructure. If one person is running 100 autonomous agents that never sleep, the compute power required for that continuous reflection and execution is astronomical.
My laptop would melt trying to run a fraction of this locally.
Oh, instantly. The physical cost of all this digital labor is immense.
And we are currently in the midst of a global compute arms race. We are seeing a historic build-out of physical infrastructure to support these agentic workflows.
It is shifting the foundational layer of the global economy toward AI data centers. The geography of compute is being rewritten based entirely on physical and economic constraints.
The source text highlights some very specific geographical hubs.
Right. For instance, in the United States, we are seeing massive clusters of gigawatt-scale data centers emerging in regions like Texas and Arizona.
The hyperscalers, NVIDIA, Microsoft, Google, Amazon, they are pouring hundreds of billions of dollars into these specific locations.
And they aren't choosing Texas because of the tech culture.
No, they're choosing it for the cheap, expansive land.
The relatively strong electrical grid capacity.
And the favorable zoning regulations. Cities like Dallas and Phoenix are becoming the global hubs of AI physical infrastructure simply because they have the space and the power to accommodate facilities housing hundreds of thousands of GPUs.
But the United States does not have a monopoly on this infrastructure.
Right. The Middle East, particularly Saudi Arabia and the United Arab Emirates, is aggressively leveraging its energy abundance and massive sovereign wealth capital.
They are bypassing the incremental approach and building what are essentially entire cities dedicated to AI compute.
Gigawatt-scale AI campuses.
Yes. They have the sovereign backing to secure the energy grid and the capital to purchase the hardware at an unprecedented scale.
Then you have a completely different geographical strategy in places like the Nordic regions, such as Iceland or Norway.
This is fascinating because when you are running a data center at this scale, the processors generate a massive amount of heat.
Cooling those servers is one of the highest operational expenses.
Exactly. And the Nordics offer incredibly cheap, renewable geothermal and hydroelectric energy combined with naturally freezing climates.
They literally just pump the outside air through the facilities to cool the GPUs,
drastically reducing the energy overhead.
This highlights the ultimate bottleneck of the agentic era: energy.
Training a frontier model and then running millions of continuous autonomous inference loops requires gigawatts of power.
The transition toward an AI-driven economy is simultaneously forcing an energy transition.
We are seeing tech companies heavily investing in nuclear power, backing next-generation small modular reactors, and expanding geothermal capabilities.
Energy availability will ultimately dictate which nations control the future of AI.
Which transitions us into a critical geopolitical reality.
Yes, sovereign AI. And to be clear to you listening, we are reporting on this purely as a strategic and economic trend outlined in the text. We're taking sides on the international tech competition here.
Right, maintaining an impartial view of the global landscape. The core premise is that as autonomous systems become deeply embedded in global supply chains, financial markets, and software development, governments are recognizing a profound vulnerability.
They cannot rely entirely on foreign corporate infrastructure for their basic economic functions.
And this has sparked the race for sovereign AI. Nations are demanding domestic control over the entire AI stack.
They want the foundation models trained on their cultural data,
The data centers located within their borders.
and the physical compute hardware controlled by domestic entities.
The United States, China, India, France, Germany, and South Korea are all executing massive national strategies to secure this sovereignty.
The strategic logic is straightforward. If agentic workflows are going to run the foundational processes of your economy, outsourcing that capability is akin to outsourcing your national power grid.
It fundamentally changes how nations view compute power. It is no longer just a commercial product, it is critical national infrastructure.
But let's bring this back down from the geopolitical level to the practical reality of deploying these systems.
Yeah, let's talk about the risks.
Because the idea of giving an autonomous AI direct access to your company's bank accounts, your AWS servers, and your customer databases sounds inherently risky.
It is.
What happens when the agent makes a mistake? What are the actual risks of implementing agentic workflows?
The text outlines 4 major risks, and they are substantial. The first and most immediate is runaway automation,
Because these agents operate autonomously in tight iterative loops.
executing actions at computer speed. So a slight misunderstanding of a goal can trigger a cascade of unintended actions.
If an agent has a bug in its logic and decides to aggressively delete redundant files in a database,
It could wipe out critical infrastructure before a human operator even realizes what is happening or has the chance to hit a kill switch.
then there is the massive expansion of the attack surface, which leads to the second risk, security risks.
If an agent has authenticated access to your external tools, your Stripe API keys, your GitHub repository, your internal Slack channels,
It becomes the ultimate target for bad actors.
attackers don't need to breach your highly secure database directly. They just need to find a vulnerability in the orchestration layer of your AI agent and exploit its permissions to bypass your security protocols.
The third major challenge is the alignment problem, applied to autonomous action.
Even with highly advanced reasoning models, ensuring that an agent acts perfectly in accordance with the nuanced, often unstated intent of the human operator is incredibly difficult.
The classic example. If you give a growth agent the objective to maximize user engagement on the platform,
Does the agent decide to aggressively spam your users with sensationalized notifications?
it technically achieves the goal.
But it violated your brand's ethical standards. Ensuring that execution remains aligned with complex human values is a largely unsolved technical challenge.
And finally, the fourth risk. We have to acknowledge the economic disruption.
While the solo unicorn sounds great for the founder, the rapid hyperautomation of entire knowledge work sectors could severely disrupt the labor market.
Copywriting, junior development, basic legal research, data analysis, entire industries could be wiped out rapidly.
And this creates massive governance and regulatory vacuums.
Right. If a fully autonomous AI-run corporation violates a trade regulation or engages in discriminatory pricing, who is legally accountable?
The human who set the vague goal, the orchestration framework developer, the foundation model creator.
How do you even audit the internal reflection loops of a multi-agent system to prove intent? We are sailing into entirely uncharted regulatory waters.
We certainly are. But despite these systemic risks and the macro-level uncertainties, the technology is available right now.
And for professionals and businesses, the cost of ignoring this shift is likely higher than the risk of experimenting with it.
So we need to provide a practical, actionable blueprint for you, the listener. How can you start building and integrating agentic workflows today, even without a gigawatt data center?
There is a 6-step methodology from the source for startups and individuals to start building these systems today. Step 1 is absolutely critical. Define a narrow use case.
The biggest mistake people make is giving the AI a broad, ambiguous goal like, grow my business.
It will fail. You must bound the workflow. Choose a specific, painful bottleneck in your current operation.
For example, automate the initial prospect research and draft personalized outreach emails for Tier 2 sales leads.
It is narrow, it is measurable, and it has clear boundaries.
Once you have that bounded use case, step 2 is choosing your foundation model. You cannot cheap out here.
Right. Agentic workflows require high-level reasoning to navigate edge cases. You need to route your orchestration framework to models like GPT-5.4, Claude, or Gemini.
Using a weaker model for an agentic task will result in endless loops of failed execution because it lacks the cognitive depth to self-correct.
Step 3 is where the magic happens. Add tools.
This is where you transition the model from a chatbot to an agent. You use an orchestration framework to connect the model to your actual software.
Give it read and write access to your CRM. Connect it to your email client via API. Give it web scraping capabilities.
You have to give it the hands to manipulate the digital environment.
Step 4 is building the memory architecture. As we discussed at length, autonomy requires context.
You need to implement a vector database to track past actions.
If the agent is handling sales outreach, the vector database ensures it remembers that it already emailed a specific prospect 3 weeks ago.
So it doesn't send a redundant, embarrassing introductory email. Memory creates continuity.
Step 5 is establishing the feedback loops. The agent needs a mechanism to evaluate its performance.
You must define the metrics of success. Open rates, task completion speed, positive reply rates.
And feed that data back into the agent's reflection loop.
Without a feedback mechanism, the agent cannot optimize its procedural memory. It will just repeat the same average performance indefinitely.
And finally, step 6 is deploying multi-agent systems. You do not start by building a 10-agent corporate team.
You start with one highly effective, narrow agent.
Once that agent is reliably executing its workflow, you introduce a second agent to handle the next step in the pipeline.
You scale the complexity gradually, building your digital workforce one specialized role at a time, ensuring the orchestration layer can handle the communication overhead.
So what does this all mean? The overarching shift here, we are looking at a fundamental blurring of the lines between software and organization.
Companies themselves may increasingly function as AI systems wrapped in a thin layer of human oversight. The concept of an AI operating system is becoming reality.
The interface of the future isn't a desktop filled with isolated application icons.
You won't open a spreadsheet program, then open a browser, then open a communication app.
The interface will be a continuous natural language dialogue with a central AI orchestrator that manages all of your specialized agents in the background.
You will interact with your computer the same way an executive interacts with a chief of staff.
The reality is that agentic workflows do not eliminate human relevance, but they absolutely demand a shift in your skill set.
Your role is moving decisively from the operator to the strategist.
In the coming decade, the most valuable skills won't necessarily be raw programming syntax or clever prompt engineering.
The premium will be placed on the ability to design complex systems, direct intelligent agents, govern their ethical boundaries, and define the creative vision.
Focusing on vision, creativity, ethics, and leadership, you are stepping into the role of the CEO of your own digital workforce.
That is the ultimate trajectory. But if we extrapolate on the deep implications of this shift, it leaves us with a rather profound, almost philosophical question regarding human expertise.
The intuition gap.
Exactly. Historically, our deepest mastery, our most profound innovations, and our sharpest intuitions have been forged in the friction of the doing.
We learn the elegant structure of great code by spending agonizing hours debugging bad code.
We learn the nuances of effective communication by struggling through the drafting process.
If the execution of knowledge work is entirely offloaded to our AI counterparts,
If we only ever act as the overarching strategist and never the operator in the trenches.
how do the strategists of the future develop their intuition in the first place?
If we remove the friction of the process, do we also remove the catalyst for human mastery?
That is an incredibly heavy, fascinating thought to end on. How do you effectively lead a workforce if you have never had to grind through the operational realities yourself? Navigating that tension between strategic oversight and operational disconnect is going to be the defining challenge for professionals in the age of agents. Thank you for joining us on this deep dive into the architecture and implications of agentic workflows. We hope this custom-tailored exploration helps you cut through the hype and start thinking about how you can act as the manager of your own digital workforce today. Keep challenging the systems around you and keep exploring.